Hello everyone and welcome back to Cherry's online classes. Today we are going to learn about tension force. In the last class you learned about normal force. That is when an object is placed on the tabletop. The tabletop exerts a force which is equal to the weight of the object in the upward direction. That is the normal force. Isn't it? That is because the tabletop is acting force on the object in the upward direction to actually support it, or you can say it is actually acting force to resist compression. Otherwise the tabletop will get compressed. Okay, so it is working against the compression of the tabletop. Now in this tension you find that the two objects are not coming in contact directly. You are actually tying using a string or a cable like this, which is flexible, and you find that when the object is suspended, the string is stretched down. Therefore the string will pull the object in the upward direction to resist stretching. Okay, so now look here. Here you can see a weight suspended using a string. Now you know the weight of this object is acting in the downward direction, but it is not moving down. That is because the string is pulling it in the upward direction. That is a reaction of this weight. So that upward force exerted by the string on the object is what you call tension. It is a pulling force. Remember, it is a pulling force to resist stretching. This is exerting, the string is exerting force in the upward direction to resist stretching. That you remember. Okay. Now remember, the force exerted by the object in the downward direction, the weight of it is transmitted through the string, and therefore you can say it always acts along the string, parallel to the string. Okay, and the tension is also along the string, parallel to it, and you find that tension at every point is same. Every point in the string is same. Okay, tension is acting in the upward direction, weight in the downward direction, and tension is equal to the weight. That is why the weight is not moving in the upward direction. Remember, tension is equal to the weight of the object in the upward direction along the string. Okay, the force is transmitted through the string. Now, how do you know there is tension in the string? That you can see when if I cut from here. Suppose I cut the string from here, what happens? The weight will fall down. Other than that, what do you observe? You can find a jerk in the string in the upward direction. A sudden jerk you find. That is because of the tension in the upward direction. Now you just have a look at it. I'm going to cut it. You can see the string moving in the upward direction. Okay. So it goes up and then comes down. Comes down due to the weight of this. But first it moves up, which shows that there was tension in this string when the weight was hung on it. Is that clear? Now if you use a free body diagram to represent tension, you can show it like this. Here you can see a rigid support, and using a string you are actually suspending an object. The weight is acting in the downward direction, tension in the upward direction, and tension is equal to the weight of the object, which is equal to mg. So tension is always marked on the string in the upward direction. Is it clear?